Welcome to this video in which we will solve an entire past paper together. Paper 33 of May, June 2014, which is a core exam. It's important to realize that you have 2 hours time, and you can bring a calculator and you will be given tracing paper which you can use during the exam. And you can also bring a compass, protractor, rulers and everything else, and you make sure that if your answer is not exact, your final answer, correct to 3 significant figures or 1 decimal place if it's an angle. Okay. All the credit before we start goes to Cambridge Examinations because these are their questions, they have made them, we're just here to solve them together. I'm Mr. John from explainingmaths.com. Let's go to question 1. So we're at question 1 and looking at the diagram, you already know this is something to do about transformations. You have different transformations, you have reflections, you have rotations, enlargements, translations. These are all different types of transformations. And a transformation that moves an object or changes the size of an object. Okay. For 4 shapes it says A, B, C and D are shown on the grid. A, B, C and D. D is slightly larger. Describe fully the single transformation that maps A onto, and then they say B, C or D. So 2 points, 3 points, 3 points, because you need to give all the information for each type of transformation. Okay, it's already quite a difficult question to start with, but you can do it. A onto B. Now it looks as if it is a rotation. However, if you would rotate A, it will not go exactly on top of B, because the L for B is mirrored. You see that? So if you would rotate shape A, the L will look like this. Okay, so it's not a rotation. Well, it's not a translation either, because a translation you just pick up the shape, and put it somewhere else, but it will look exactly the same. It's not an enlargement because it's not bigger or smaller than A, so it has to be a reflection. So you're going to say a reflection, right there, reflection. But you have to describe it fully, and for a reflection you have to give the equation of the mirror line. What is the line of reflection? And you can use your ruler for that, but if you want, but hopefully you realize, I don't have a ruler, I tried best, I'm just sketching the line now. You realize that that line, that mirror line, should be somewhere between A and B. So you're going to try, they're never going to give you the most difficult line. It's either a vertical line or a horizontal line. When it's a diagonal line, it will go through the origin. Most likely this one, let's just check that for that point. If I go 1, 2, 3 down, I indeed go 1, 2, 3 to the left. Yeah, so that makes sense. So reflection, and then you say the line y equals minus x. It's your line of reflection. Moving on, shape C. It's a difficult question to start with, I have to say. But okay, yeah, not everything in life has to be easy. To shape C, so from A to C. Now that's not going to be a reflection, you've already done a reflection for 3 points, so you're probably going to have to give a little bit more information as well. It's not an enlargement because it's the same size, it's not a translation because it's not just translated, so it has to be a rotation. Yeah? So you're going to write down a rotation, there you go, rotation, but you got to give all the information. Rotation, got to give the center of rotation, the amount of degrees, which is always going to be 90, 180 or 270, which is 90 the other way, in the other direction, and you have to give the direction. Okay, you can use tracing paper for this. I can't show you on the tablet, but if you use tracing paper and you trace the original shape, shape A, and just put your pen somewhere where you think, well, that may be the center of rotation, and you rotate the tracing paper, and then shape A should go exactly on shape C. Check my website, explainingmaths.com, where you will be able to see this. I can't do this on a tablet, so a trial and error, okay? But hopefully you realize that that center should be somewhere, again, between the shapes A and C. And if you try that a couple of times with the tracing paper, and that will only take perhaps 1 minute, you will notice that the center is a coordinate 3, 2, yeah? So that will be the center of rotation. So you got to give that 3, 2. There you go. It's the center of rotation. But you also have to say how many degrees. That's going to be then 90 degrees anti-clockwise, because you also have to give the direction. That's why you get some more points for this one, clockwise, because you have to give more information. So anti-clockwise So in that direction, 90 degrees. You could say 270 degrees clockwise, but it makes more sense to say 90 degrees anti-clockwise. Shape A onto D, well, that's clearly an enlargement. There we go. So let me write that down. Enlargement. Enlargement. But also for an enlargement, you have to give more information. You have to give the scale factor, how many times is it bigger, but you also have to give the center of enlargement. Now the scale factor is perhaps the obvious one, so let's start with that. This has a length of 3, the base, and this has a length of 1, 2, 3, 4, 5, 6. So the scale factor is 2. Scale factor is 2. Excuse me. Let me check that for another side. For instance, this length is 1, 2, 3, 4, and here originally indeed it was 2. So scale factor is 2. But now the center of rotation, center of enlargement, excuse me. How can you find that? Well, then you connect some corresponding points with a line. And I'm going to do that on top of my tablet. You can do a better job on the piece of paper. But this point corresponds with that point of the original shape. So I'm going to connect those 2 points with a line. And I'm going to do that with a couple of points. And then where those points intersect, that is going to be the center of enlargement. Okay? Well, this point corresponds with that point of the original shape. So I'm going to make a line. And again, you can do a better job on a piece of paper than I can on a tablet. But I see there's already a point of intersection there. So that is going to be my center of enlargement. Let me just check that for one other corresponding point. That one corresponds with that one. And I'm going to connect it to, there we go. And indeed, well, it's not very accurate, but I've said it a couple of times now, I do this on a tablet, but it will go exactly through that point if you do that on a piece of paper. So what is the center? The center is coordinate 3 minus 2. There we go. Let's go to the next page for some more transformation questions. So not really a transformation actually, it says shade in one more, it's in bold, so shout that out in your head when you're reading it. One more square, so this shape has a rotational symmetry of order 2. Now rotational symmetry is if you would rotate the shape 360 degrees, I'm not sure if I can do that now, if I would turn it around, yeah, there we go, 360 degrees, then of order 2 means it must look the same as the original shape twice, and that includes the final position. Okay, so I just have to find a square that if I would turn it around, it looks the same as what it does right now. Okay, so let's have a see. Well, if I, for instance, if I do this one, if I would color that one in, there we go. Yeah, see the symmetry now, because if I, can I still move it? If I turn it around now, yes I can. It looks the same as the original position, so that's 1. And I keep turning it, okay, that was 360 degrees, so that is 2. That is rotational symmetry of order 2. There you go. And then question I reflect this shape in the line of symmetry shown. So that's the line of symmetry. And you do this, of course, with a ruler and a sharp pencil. And you draw the same, or you draw the reflection on the other side. So it's 3 blocks there, 1 down, and then 2 more, but now then to the left. I don't want to do that diagonal yet. Let me continue with this one on this side. So it's 2, 1 down, 1 in that direction, 2 down, and then you can draw the diagonal. And all of this, of course, you should do with a ruler and a sharp pencil. And I just do this on a tablet, so it's not very, it doesn't look very nice, but I'm sure yours is looking better. Okay, let's go to the next question. Question 2 starts by saying a group of students take part in their school's sports day. Fantastic, much more fun than maths, playing sports. The length L that Anna throws the javelin is 23.6 meters. Oh, well done. Correct to the nearest 10 centimeters. Okay, so these are meters, 23.6, correct to the nearest 10 centimeters. Complete the statement about L. So they're asking, what is the lower bound, what is the upper bound? Okay, How do you approach that? Write down 23.6 and write down that to the nearest 10 centimeters. So the next one would be 23.7. And the previous one on the number line would be 23.5, because these are the 10 centimeters, the decimals, because that unit is meters. Okay, that is on the lower bound, that's on the upper bound. No, the lower bound will then sit exactly between 23.5 and 23.6. Now you could add the 2 divided by 2, and then you'll get 23.55, and the upper bound will be exactly in the middle there, 23.65. Yeah, so that is the lower bound and the upper bound. Fantastic. 2 points, 1 point for each. Billy throws the hammer a distance of 8 meters on his first throw. His second throw is 15% further. Calculate the distance of his second throw. Well, there are several ways of calculating percentages. I'm just going to write down what I prefer. Okay, so 8 meters is everything, and I'm going to divide that by 100 and times that by 15%. Okay, and I'm going to grab my calculator to do that. 8 divided by 100 equals times 15. And that is 1.2. But that is further. So his new distance is going to be 8. His original length plus 1.2. So the answer 9.2 meters. And I said before, there are several ways of doing it. You could also do 8 times 1.15, and there are other ways of doing it. Carl runs 100 meters of a speed of 8 meters per second. Calculate the time it takes for him to run 100 meters. Okay, how many seconds? Now, if you sit in the car with your parents, you will notice that the speed, how fast the car is going, is always given kilometers per hour or miles per hour, depending on where you are. It's anyway always a distance over time, right? That will give you the speed. There you go. The speed in this case is 8 meters per second. Check those units, but to make sure that we're talking about the same units, 8 meters per second, and the distance is 100 meters. So that is both meters. So the distance, I'm just going to squeeze it in here, over the time. So 100 over the time equals 8. The distance over the time equals 8. Now some of you, perhaps from your teacher, you learn these pyramids to find speed, distance or time, depending on the information they give to you. But the time, and you can use those pyramids if you want. The time is going to be 100, so the distance over the speed. And that is 12.5. Your calculator will do that for you, 12.5. Now, that makes sense. If you do 8 meters in 1 second, then it will take you 12.5 seconds to do 100 meters. 8 meters after 1 second, 16 meters after 2 seconds, 24 meters after 3 seconds. That's how you can continue. So always make sure that your answer makes sense, because perhaps you have turned the numerator, denominator around. You get a silly answer there. Okay, change his speed to kilometers per hour. Okay, so it is the best way to approach that is to first write down his original speed really as a fraction like this, 8 meters per second in 1 second. And then we're going to change each unit into the next unit. So 8 meters, how many kilometers is that? Well, that is 8 divided by 1,000 kilometers. It's not 8 times 1,000 kilometers. 8 meters is not the same as 8,000 kilometers. It should be a small number. And 1 second is the same as, how many seconds are there in 1 hour? 3,600. So divided by 3,600. Okay. If you then plug in your calculator, 8 divided by 1,000 equals, and you divide that by, now make sure you use brackets, 1 divided by 3,600 brackets, then your calculator is going to say 28.8. So that is the same speed, but now using different units, 28.8. Again, there are several ways of changing those units. This is what I always do. So I look at the distance, convert that to kilometers. I look at the time, convert that to hours, but make sure if you put it in your calculator that you do some brackets there, so you're giving the right command to your calculator. Okay, moving on to the next question. 10 students take part in both the long jump and the 100 meters hurdles competitions. The results are shown in the table below. So you have 10 students, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? The distance and the time. Okay, fantastic. We're going to the next page to see what we are going to do with that information. So the first question is to complete the scatter diagram. And they say the first 6 points have already been done for you. 1, 2, 3, 4, 5, 6. But I have also already done the remaining 4, just to save some time for you. Now, what you need to be really conscious about is the scale. Okay, so horizontally it goes from 3 to 3.5 in 5 blocks. So that means that each step, each block is 0.1. Yeah? 3.0, 3.1, 3.2, 3.4, 3.4, 3.5. Okay. However, vertically, in those 5 blocks, they go from 14 to 15. That means that each block is 0.2, 0.4, 0.6, 0.8, and then to the next whole number. Now, if you're not sure how to work that out, what the scale is, then you look at the difference, so 3.5 minus 3, and then you divide that by the amount of blocks you count, 5. And then you're going to get 0.1. And vertically, the difference, 15 minus 14 is 1, divided by 5, then you know that each block is going to be 0.2. That is important because if you plot these 4 points, you have to plot them exactly where they have to go. So if I look at that first point, that will be 4.1, 0.2, 4.3. And if I go up, 15, 15.2, 15.3. So exactly between 15.2 and 15.4. All right. Then we go to question II. What type of correlation does this scatter diagram show? So as you can quite clearly see that the data is going down like that. So it is a negative correlation. So that's what you write down, negative. There we go. Describe the relationship between the distance in a long jump and the time for the 100 meters hurdles. Okay. So the distance, so how if the distance increases, so the further somebody jumps, if the distance increases, the quicker they can finish that 100 meter hurdle sprint because the time goes down. So the longer the distance, the quicker the time. So that is what you can write down here. The longer the distance, for the long jump, the quicker the time for the hurdles. I'm not going to write it out for you. I hope you get what I'm saying. And then on the grid, draw a line of best fits. Now that is always a little bit tricky. What are you trying to do? You're trying to draw a line, and your aim is to get as many points on your line as possible and roughly the same amount of points just above the line as just below the line. Now there's not one correct solution for this, but you have to be really accurate to remain in the boundaries which are acceptable. Okay. So I'm going to I'm now literally putting a ruler on my tablet. I'm going to try to do that for you. Let me see. I'm gonna do that roughly like this. Let me see. Okay. There we go. Oh, sorry. See? Oh, that's a problem. I have to do it again now because I've got to click my pen. Sorry about that. And taking my ruler, placing it on the screen, well, roughly like this. Maybe you can do a better job, okay? But you're going to try to get as many points on the line as possible. So I could have gone a little bit down, to be honest, because then I would have probably those 3 points on the line. Yeah, and some will be below and some will be above. Okay. What do we have to do then? Probably something with the line. Another student jumps 3.5 meters in the long jump. Use your line of best fit to estimate the time for this student in the 100 meters hurdles. So 3.5, and I'm going to use my line. So what am I expecting him, how quickly am I expecting him to finish the 100 meter sprint? So I will draw this line from 3.5 to there, so I would expect him to do that in 17.0 seconds. There you go, 17.0. Okay, moving on. A different student jumps 5.2 meters in a long jump. Explain why you should not use your scatter diagram to estimate their time in the 100-meter hurdles. Let me see, 5.2. Well, that would be below my line. Is that right? I just see. If I just draw the line a little bit longer. Yeah, 5.2. It's not on my line. Let me just, if you go back to the data as well, you will notice, if you go to the back one page, and you look at the table, you will notice that 5.2 is outside of the range. It's not in the table, okay? So you cannot estimate his time because it is outside. It's outside of the range of data. Yeah, I cannot flick back a page, but you can. So go back a page, look at the table. It's outside of the range, and as you can see, yeah, it will not be on my line. So I cannot make any predictions for that particular student. Let's go to the next question. So the Wong family spends a day at the zoo. Well, that's very nice for them. It has 2 adults, 3 children, age 2, 5, and 11. And as you probably already know, for kids, if you're a baby, like, you can go in for free usually when you go to the zoo, and for kids it's a reduced price. Mr. Wong pays for his family to go into the zoo using a £50 note. Okay, that's important. Work out the change he receives. So they're not interested in how much does he have to pay. Yeah, well, they're also interested in that, but they also want your final answer should be the amount of money that he gets back. Okay, so 2 adults, so 8.50 times 2, and please write down these workings because that's how you get those points in to show your examiner what you're doing. So that is £17. That's for the 2 adults. Then we have 3 kids aged 2. Well, that one will be for 3. I'm just going to write it down for 3. Aged 5 and 11. So the aged 5 will have to pay $4.50, and the aged 11 $6. So $4.50 and 6. So 17 for the dollars, 3 for the baby, $4.50 and 6. Now I'm a little bit tired. I'm going to use a calculator for this. 17 plus 4.5 plus 6 equals 27.5, 50 cents. Okay, be careful because that's what he pays, but they're interested in the change, 27, so you have to look at the difference, and then if you plug that in your calculator, if you have to, you notice it's going to be 22.5, and I say 50 because we're talking about money, so cents, 50 cents. The dolphin show finishes at 11:05. It lasts for 1 hour and 20 minutes. Write down the time that it started. All right, so 11:05, going to go back 1 hour, then 10:05, and then another 20 minutes. So another 5 minutes, it's 10 o'clock, and then another 15 minutes, it's going to be 9:45. So 09:45. Always a bit tricky with time, working backwards. So let's just check that, 1 hour and 20 minutes. So we're sitting there looking at the dolphins. So after an hour, it's going to be 10:45 plus another 20 minutes, 11:05. Yeah, it's correct. Torty the tortoise, do I pronounce it properly? Tortoise, was born 27th of December 1898. Yet again, get quite old. Work out how many years old he was on January the 3rd, 2003. And it's a little bit tricky because they talk about, okay, so the 27th of December when he was born, and how old was he on the 3rd of January? Yeah? So the new year just started there. So you got to look at basically 2002, because the 27th of December 2002, it will be his birthday, and only a few days later, 3rd of January 2003, he will still be the same age as in 2002. Does that make sense? Anyway, so let me just write down that in 1998 he would be 100 years old, and we have 99. What is it? 2000, 2001, 2002, 2000. Okay, let's go to 2003. So 101, 102, 103, 104 and 105. So yeah, in 2003 he turns 105, but that is all the way in December 2003. But in January 2003 he will be 104 because just a few days earlier he had his birthday. So 104 will be his age. There we go. Last year, the ratio snakes to lizards, 3 to 5. Okay, so more lizards than snakes. There were 45 lizards. Work out how many snakes there were. Okay, so the lizards have 5 boxes. If there were 45 lizards, then 45 divided by 5, it will be 1 box. And the snakes have 3 boxes, so you multiply that by 3. So that's 9 times 3. The answer is 27. Okay, so the way you got to look at that, and you can check my site where I explain that in more detail, but just to make sure you understand the ratio, you have snakes and lizards, and the snakes have 3 of those boxes, and the lizards have 5, and you're just interested, so how many animals are in each box? So if the 5 boxes is 45, yeah, that means that in each box, it should be 9, yeah, 45 divided by 5. So the snakes have 3 of those boxes, 27. This year there are 3 more snakes and the same number of lizards. Write down the new ratio snakes to lizards and give your answer in its simplest form. Because ratio you always have to give in the simplest form. So snakes to lizards, there were 27, 3 more, so you have 30 now to still 45 lizards because that remained the same. So get out the highest common factor. Well, I can see I can divide both by 5, so 6 to 9, but I can still divide both by 3, so 2 to 3. So that is the simplified ratio, 2 as a ratio to 3. Last question here, I believe, question E. It says Mr. Wong hires a vehicle to drive around the zoo. The cost is $25 for the first hour and $7.50 for every extra half hour. And he has to pay $85 altogether. For how long does he hire the vehicle? Now you can do this with trial and error if you like, but if he pays $85 at the end, and he anyway had to pay $25 for the hire, so he paid $60 extra. For every half hour he pays $7.50. So if I do 60 divided by 7.5, let me just plug it in my calculator. 60 divided by 7.5, which gives me an answer of 8, means that 8 times he had to pay something extra. Now I'm going to continue here on the side. I do apologize, trying to squeeze in all the answers here on one page. It's a little bit confusing. But 8 times he had to pay an extra $7.5. And that was for every half hour. So those are 4 hours in total. Okay, 4 hours in total. So 8 half hours, 8 times 750, 8 half hours. So 4 hours in total. However, for the first hour he paid already the $25 anyway. So that was for the first hour. So in total he is sitting or renting that car for 5 hours. Let's go to the next page. So we're still talking about Mr. Wong, and he wants to buy some food for the giraffes. This is a really kind gentleman, Mr. Wong. Small bag, medium bag, large bag, different weights, different prices. Work out which bag is best value for money and show how you decide. Okay, excellent question. This is what I do all the time in supermarkets, and you can get a bigger portion of something, but of course you're going to pay more for it, and I'm always trying to work out, is it actually worth it, or should I just go for the smaller package? Different ways of doing it. But you need to make sure somehow that the weights are the same of those 3 bags, and then you can compare the price. Okay. So for the small bag, so for every 100 gram, yeah, I have to pay 60 cents divided by 2.25. Do we understand why? While I work it out, 60 divided by 2.25 equals 26. Yeah, 2 over 3, 26.7 for every 100 grams. And why do I divide it by 2.25? Because 225 divided by 2.25 is 100 grams. Okay, so for every 100 grams in the small bag, you will pay 26.7, if you like, cents. I'm going to do the same for the medium bag. However, For the 100 grams in a medium bag, I'm going to pay 70 divided by 2.5 because the 70 cents is for 250 grams, so divided by 2.5 to find out how much I would pay for 100 grams. 100 divided by 2.5. There are other ways of doing this, by the way, is 14. There are other ways of doing this, but this is just one way to equal the weight or the mass of each bag to each other. The third bag for 100 grams, there I'm going to pay 90 divided by 3.25. 90 divided by 3.25 equals, that's 9 divided by 3.25. That didn't make sense. 90 divided by 3.25. Sorry, my calculator is not helping me. 27.7. If I correct that to one decimal place. 27.7. There you go. So actually, which one is the cheapest for 100 grams? That is the small bag. There you go. So there are different ways of doing this. This is just one method. The diagram shows a map of the zoo. The scale is 1 centimeters, represents 50 meters in real life. Yeah? There you can see the scale also on the side. Measure the bearing of the flamingos from the entrance. Okay, so a bearing is always starting from the north in a clockwise direction. So what you could do, you're going to need a protractor to do this. What you could do to help yourself is to draw the line, and you can do a better job than I can. This is on a tablet. Draw the line entrance to the flamingos. Perhaps extend the line to the north and do that accurately. Extend the line to the north, and then you're interested in this angle from the north in a clockwise direction. And if you do that properly, you're going to get exactly 105 degrees. Yeah? So you're going to use your protractor and measure that angle. Xanthi, what a beautiful name, looks after all the animals within 200 meters of the exit. Okay. Draw accurately the locus of points inside the zoo, which are 200 meters from the exit. Well, first then you have to look at the scale, of course. 1 centimeter represents 50 meters. So 200 meters away is going to be how many centimeters? Well, that is 5 times 4 is going to give you 200. And if you don't know that times 4 is going to give you 200, then you could do 200 divided by 50. You'll see, that's 4 times as large. So on my map, that also needs to be then 4 times as large. So 4 centimeters. 4 centimeters. Draw accurately the locus of points inside the zoo, which are 200 meters away from the exit. Okay, so the exit is here, and then all the points 200 meters away, so 4 centimeters away, you have to use your compass. Okay, now I can't do that on a tablet, but you open your compass 4 centimeters, and then you draw the arc of your circle, that part of the circle inside the zoo. Now, I'm going to try the best I can with a ruler, but you have to use a compass. So you open your compass exactly 4 centimeters, and then you draw the arc, so that part of the circumference 4 centimeters away. And then you're going to get something, and yeah, this is terrible, but I just can't use a compass on my tablet, but something like this. Okay, so you are not interested in the rest of the circle because that is outside of the zoo. Yeah, so you're only interested in this part inside of the zoo, exactly 4 centimeters away from the exit. Yeah? So with a radius of 4 centimeters, you should draw that part of the circle. A shop S is on a bearing of 212 from the entrance and a bearing of 293 from the exit. Mark point S on the map. Okay. 212 from the entrance. Let's start with that. So you're going to get your protractor again. And you're going to measure the angle 212 from the entrance. And for me, let me see, I'm putting the protractor on my tablet. And you have to do that accurately, of course. Where with 212, so that for me is going to be over here. There we go. And then you take your ruler. And you are going to draw the line. I'll do that in black. So from the entrance There you go. That is the bearing of 212, and I'm trying to do this as good as I can on the tablet. So somewhere on that line is going to be that shop. They're going to give more information. 293 from the exits. I'm going to do a similar thing, but now for the exits. So I put my protractor at the exit, and 293. So you got to make sure you're able to use a protractor properly. Is roughly there, and it's not super accurate. You have to do a better job. I am on a tablet. That is not in my advantage. So that is a bearing of, there you go, 293. So that means that on the intersection, the shop will be shop S. Hopefully that was clear enough for you. Otherwise check my website, explainingmaths.com, where I explain this in a little bit more detail perhaps. The age of 15 children who go to a swimming club are shown below. So 15 kids and their age 10, 11, 12, 13. Complete the frequency table. You may use the tally column to help you, although you don't have to, okay? 10 kids, how many? 1, 2, 3 of them. So you could use the tally 1, 2, 3. So you say here 3. And put a little line through the 10 so you know you have done them. 11, 1, 2, 3, 4, 5. There we go. 12, 1, 2, 3, 4, 5, 6. And 13, just one of them. Now, sometimes you make silly mistakes, so we just want to make sure that this adds up to 15, 8, 9, 15. It does, so that must be correct. For the ages of the 15 children, find the range. Now, what is the range? That is the largest number. Take away the smallest number. So the largest number, age is 13, and the youngest kid was 10, so the range will be 3, 13 minus 10. What is the mode? So what is the age of the highest frequency? So that is a frequency of 6, so the mode is going to be 12. The median. Now for the median, you first have to organize your data. So we're going to put it in a list. I have a 10, 10, 10. Yeah, organize, I mean I write it in ascending order. Then I have 5 11s. 1, 2, 3, 4, 5. 6 12s. 2, 3, 4, 5, 6, and a 13. And then the median lies in the middle. Okay, so I'm going to cut away at the start and at the end pieces of information. Well, it's going to take an ages to get there, so I'm just going to do 3, 1, 2, 3, and I'll slow down again, 1, 1, and then you can see that the median is 11. There you go. And then the mean for 2 points. So you want to show some working. You have to add them all up. So you can do 10 plus 11 plus 10 plus 12 plus 12 plus, or you could do, which is going to give you the same answer, so it doesn't matter. I have 3 10s, look at the frequency table, plus 5 11s, plus 6 12s, plus 1 13. And all of that I divide by the amount of pieces of information, so 15. There we go. And then your mean is going to be 11.3. Now, does that make sense? Because we always check, we make some silly mistakes. Some people divide by 4 because they say, oh, 1, 2, 3, 4. But no, it's really 15 kids. It's between 10 and 13, so a mean of 11.3 makes sense. Yes, if you have a mean of 30, that wouldn't make sense because the highest value is 13. So you can never get a mean of 30. All right. One child is chosen at random from the group. Write down the probability that the child's age is 10. So the chance, that's 3 people are 10 out of 15. So that is 3 out of 15. And if you like, you don't have to. You can simplify that 1 over 5 or even give it as a decimal if you want. What is the chance? Write down the probability that the child's age is more than 13. Well, it's impossible because the oldest person is 13. So 0. It's a chance of 0, more than 13. If they would say 13 or more, then the chance would be 1 out of 15. But if they say more than 13, that's a chance of 0. Impossible. Don't write down impossible, by the way. Write 0. We have arrived now at question 5, and it says, write down the name of a solid which is not a prism. So in order to write down a solid which is not a prism, you need to know what a prism is. And a prism is a solid, so a 3D shape, where the two ends are the same, but also everything in between is the same. So for instance, this triangular prism, if the triangle at the beginning is the same as the triangle at the end, and if I would take a knife and make a cut anywhere, I get the same triangle, then we are talking about prisms, okay? And this is a triangular prism because the cross section is a triangle. So those are prisms. So what is not a prism? Well, for instance, a sphere is not a prism. A sphere is like a football. Yeah, that's not a prism. But you could also say a cone. A cone is not a prism. So that would be an answer which is correct as well. But there are other ones like a pyramid in Egypt. Beautiful pyramids is also not a prism. We continue. A prism has a cross-sectional area of A, so that's A, and a height of h. Write down an expression in terms of A and h for the volume. So to find the volume of prisms, you take the cross-sectional area and you multiply it by the height. Like for instance you have done with cubes and cuboids. Yeah? So if I draw a cuboid here, which is also a prism, then what would you do to find the volume? You would do length times width times the height, which is the cross-sectional area A times the height. So in this case they say the cross-sectional area is A and the height is h, so the volume will be A times h, AH. The volume V of a cylinder with radius r and height h is given pr squared times the height. I say p or pi r squared times the height. Calculate the volume of a cylinder with a radius of 3 and a height of 12. 2 points we want to put some working in. So the radius is 3, the height is 12. So I'm going to say V equals pi times 3 squared times 12. And I'm going to grab my calculator because I want to write down all those decimals first. Then pi times 9, 3 squared times 12. And that is 339.2920066. So to three significant figures, 339. Ravi puts 150 identical marbles in that particular cylinder. By the way, guys, a cylinder, you know what it looks like, yeah? It's like this roughly. There we go, that's a cylinder. Okay, puts in marbles, and then he fills the cylinder to the top exactly with another 160 centimeter cube of water. Okay, so he's putting in all those marbles, so they are in the cylinder, and when all those, how many marbles? 150 marbles are in, there is still room to put in water to fill the cylinder. Find the volume of one of those marbles, give your answer correct to two significant figures. Okay, that's tricky. Yeah, don't forget to do that to two significant figures. All right. Well, we just said that the volume of the entire cylinder is 339, and he puts in. There's still room for 160 centimeter cube of water. So I'm going to take 339. I'm going to take the unrounded answer. Take away 160 centimeter cube. Because then I'll be left with the volume that the marbles use. So that's 179.2920066. So this is the volume the marbles use. That's the total volume. Take away the volume of the water. That's the volume of the marbles. And those were 150 marbles. So I'm going to take that number now. So 179.2920066. I'm going to divide that by 150 to get the volume of one marble. Divided by 150 equals 1.19528. So to two significant figures, 1.2. Fantastic. 4 points. Beautiful question. Make R the subject of the formula V equals pi r squared h. I'm making the subject, meaning isolating R. It should say R equals and then the rest. So first we can divide both sides. We want to get rid of the pi and the h, so we'll divide both sides by pi h. So I'm going to get V over pi h equals r squared. Okay, but it says r squared, so how do we get rid of the squared? Doing the opposite. So square roots of v over pi h. A little bit messy there, I do apologize, but I hope you can read that. So 1r equals the square root of v over pi h. Great, let's go to the next question, question 6. Question 6 is about graphing. They give us this set of axes, and it says on the grid, draw the graph of y equals 5 and x equals minus 3. So be careful there, these are horizontal and vertical lines. Y equals 5, that is that line where the y coordinate is 5 all the time. So I'm taking my ruler now and a sharp pencil, well you should take a sharp pencil, and draw that horizontal line y equals 5. There we go. I would suggest you label it y equals 5. There you go. X equals minus 3. So that is a vertical line where the x coordinate is minus 3. There you go. So x equals minus 3. Label your line. Write down the coordinates of the point of intersection of y equals 5 and x minus 3. So where do they intersect? Over there. And that is then at when x is minus 3 and y is 5. Write down the equation of a line parallel to y equals 5. So parallel lines, they will never meet. So this is the line y equals 5. So another line, another horizontal line, but then the equation of that. Well, for instance, y equals minus 2. Because if I would draw that line, they don't tell me I have to, but if I do, y equals minus 2 is also a horizontal line and therefore parallel. But any line, any horizontal line, for instance y equals 4 or y equals 3 or y equals 1 or whatever would be correct. Let's go to the next page. So this is still question 6, graphing, but now we're going to do something with a curve. They give us a table of values, and I believe it says, although it doesn't fit on my screen, I believe it says complete the table for 2 points. So make sure you do that properly. X squared minus 3x. When you get a negative, make sure you put it in brackets when you find out the y value. So minus 2 squared minus 3 times minus 2. So it's 4 plus 6, that is 10. And if you plug in 1, you get minus 2. If you plug in 2, you get minus 2. And if you plug in 5, you're going to get 25 minus 15, which is 10. And looking at the table of values, you already see some symmetry there, looking at the points, don't you? And you know that because a quadratic equation, you're going to get a parabola if you graph it, which is a symmetrical curve. You have a line of symmetry. So on the grid, draw the graph of x squared minus 3x between minus 2 and 5. Oh, that is very important. Yeah, that's the domain. So do not continue beyond those 2 points. Okay, minus 2 and 5. So we're going to plot the points now. I'll do that in red. And we do that very accurately. Minus 2, 10. Minus 1, 4. 0, 0. 1 minus 2. 2 minus 2. And then we go up again. 3, 0. 4, 4, and 5, 10. Okay, but it's important to realize that when you graph your curve, this is not a horizontal line. No, between 1 and 2, it goes a little bit further because that's when you get a parabola, a symmetrical curve. Okay, now I'm going to try to graph it now on my tablet, but that's going to look horrible. I'm already going to tell you in advance. So you should do a better job than I do. Go through the points, a symmetrical curve, so that is not good. But on a tablet, it's really difficult. Okay. Ooh. There we go. And up. This takes some practice also for you guys, but on a piece of paper and with a pencil, it's easier than on a tablet. So make sure you stop at those 2 points of the domain from minus 2 to 5. Now, it has to go through the points. So in this case, what would I do? I would rub it out here and make perhaps this part and do it again to make sure it goes through the point. And what else is important that you realize again that these 2 points are not connected by a horizontal line. Now you go through the points a little bit, you have your minimum and then you go up. Write down the coordinates of the lowest point of the graph. So what is the lowest point? That's a very nice question, by the way. The lowest point is exactly between 1 and 2. So the x coordinate is 1.5, and the y coordinates, you can have a look. Either you can say, well, it's about minus 2.2, Or you can plug, and that's what I'm going to do, or you're going to plug it in the original equation. So y equals 1.5 squared minus 3 times 1.5. Let me just check that in my calculator. 1.5 times 1.5 at 2.25 minus 3 times 1.5. And indeed I get minus 2.25. But even looking at it, because you do not have to calculate it, they say write down. Looking at it, if you would say 1.5 for x and minus 2.2 for y, or minus 2.3, that would be correct as well. Okay, let's move on. Well, it's Simon's birthday today, so that is excellent news. And looking at this, I already see that I will be constructing some equations soon. What is going on? Simon is X years old, and Katie is twice as old as Simon. Okay, and Bob is 8 years younger than Simon. Write expressions in terms of X for the ages of Katie and Bob. Okay, so Katie is twice as old. So if Simon, for instance, would be 7, then Katie would be 14. Or twice as old, because she times it by 2. If Simon would be 12, then Katie would be 24 times 2. But now they say Simon is X, so Katie will be 2x times 2. What about Bob, 8 years younger, so that will be x, Simon's age, but then minus 8 years younger. The sum of their ages, question II, so if you plus the two ages, is 40. Write an equation now in terms of x. Oh, okay, I was just a little bit confused, but I didn't read it properly. It says the sum of their 3 ages. So that is Simon plus Katie plus Bob equals 40. Okay, so Simon, x, plus Katie, 2x, plus, what's his name, Bob, x minus 8, equals, I'm going to say 40. There we go, 40. Of course, we have to simplify that a little bit. Well, you don't have to, by the way, but I would, because it doesn't say simplify, but I would simplify it. So x plus 2x plus x is 4x. Equals 48. There we go. Yeah, so I do x, 1x plus 2x plus 1x is 4x, and that equals 40 plus 8, so 48. Solve your equation. You see, because we simplified it, this becomes a little bit easier now. So we can do 4x equals 48. So x equals 48 divided by 4, so 12. There you go. So actually I already said 12 here, didn't I? But okay, that's just purely a coincidence. Simon's birthday cake weighs 600 grams. He eats 1/8 of the cake. Kate eats 25% of the cake, and Bob eats 0.3 of the cake. Find the weight of the cake that is left. Okay, so 600 grams. If Simon eats 1/8 of that, so I'm going to find out what is 1/8 of 600 grams. There we go. So you can plug it in your calculator, and I'm doing the same thing. That is 75 grams of the cake is gone. Then 25% of the cake, so 0.25 times 600 at 25%. So Katie, she ate how many grams? 150, yeah? 600 divided by 4 if you like. There we go. And 0.3 for Bob of 600. Let's find out. 180. And if you plus that up with each other, what is the sum? Plus 75. Then together they ate 405 grams. But the question is, how much is left? So we have to do 600 take away 405. And let me see, 600. I'm going to plug it in my calculator. I'm a little bit lazy. 195. There we go. 195 for 4 points. Fantastic. This question continues on the next page. Let's have a look. Because we're still celebrating his birthday, and his auntie gives Simon $150 for his birthday. Lucky him. That's a lot of money, especially when you're 12. But even if you're 36 like myself, that's a lot of money. So lucky Simon. He invests his money in a bank well done, at a rate of 6% compound interest. That's important. Not simple, no. Compound interest, 6%. Calculate the total amount Simon will have after 3 years. Yeah, because they could ask you how much interest does he have or whatever, but they now ask the total amount. So compound interest, several ways of doing that. Perhaps easiest is to use the formula. So he puts in $150, and then you multiply that by the percentage. Yeah, so for each year you can multiply that by 1.06. So that is the original amount, 100%, plus another 6%. But that is after 1 year. Yeah, sorry, and he is going to put it in the bank for 3 years. So you have to do that to the power 3. Yeah, for 3 years to get the total amount. So 150 times 1.06 to the power 3 equals, and that's equals 178.6524. So because it's money, I'll do it to 2 decimal places to show the cents. 178.65. Great. One of Simon's presents is a bag of sweets. He decides to eat the sweets in a sequence. All right, interesting. On day 1, it says he eats 1 sweet, then 5 sweets, and then 9 sweets, and so on. Describe in words the rule from continuing the sequence. So what is the term-to-term rule? So from 1 to 5 to 9 to 13 to 17, the term-to-term rule is add 4 every time. I hope you realize that. Write down an expression for the terms of sweets he eats on day n. So what is the nth term rule? Well, when the term rule is plus 4, you write down 4n. If the term rule would be plus 6, you would write down 6n. Okay? But you have to ask yourself the question, is my first term, is it 4 in this case? No, it's not. So what do I have to do to go from 4 to 1 in this case? Well, then I have to take away 3. Okay, so again, if the term rule is plus 4, you write down 4n, and then you ask yourself, is my first term 4? And if not, what do I have to add or subtract to go to 1 in this case? So I have to take away 3, because 4 minus 3 is 1. Now we all make silly mistakes, so we check that for instance, term 4. So 4 times 4, 16 minus 3 is 13, so that must be correct. Check my website explainingmaths.com, where I have loads of examples if you have problems with this. Okay, so I will explain it in more detail over there if you like. Let's move on. Triangles here. The triangle has an area of 30 centimeters square and the base is 10. Calculate the perpendicular height. So the area of a triangle is always base times height divided by 2. I was a little bit too quick there. Or half times base times height. And that's the area. And the area now is 30. And that equals the base, which is 10 they say, times the height over 2. And if you rearrange that, then you multiply both sides by 2. So you're going to get 60 equals 10 times the height, and then you divide both sides by 10, so the height must be 6 centimeters. There you go. Then we have a beautiful trapezium here. AB is parallel to CD. AB is 14, CD is 8. Their perpendicular distance is 7. Write down the mathematical name. Oh, well, this is a trapezium. And why is it a trapezium? Because it's a quadrilateral with one pair of parallel sides. So a trapezium, something like that. Okay, or trapezoid, I think they say in America, which is fine as well. Calculate the area. So what is the area of a trapezium or trapezoid? It's the sum of the parallel lines over 2 times that perpendicular height. So 8 plus 14 over 2 times the perpendicular height. There we go. 22 over 2, that's 11 times 7, 77. Fantastic. Is there another question here? I'm not sure. Let's find out. No, that was that for 2 points. Okay, then we can go to the next page. I'll see you there. Yeah, because I thought it has to continue. It's another question C, and there we go, on the next page. An isosceles triangle has an angle of 40 degrees. Okay, I'm going to stop there already. What is an isosceles triangle? Well, obviously it's a triangle, but isosceles means it has two lengths which are equal, and the two base angles are also equal. Okay, fantastic. Has a triangle of 40 degrees. Theta draws a triangle with angles 40, 70, 70. And Conworkpriet, okay, so 40, 70, 70, sorry, so Theta, so 70, 70, so then that one must be 70, and that one must be 70, and then the top angle 40 degrees. Conworkpriet, that's a difficult name for me, draws a different correct triangle. What angles did he use? Okay, so there's another isosceles triangle, with an angle of 40 degrees, and then you use, well, that's a very bad sketch, by the way, but then you use the base angles being 40 degrees, 40, 40, and then the top angle is going to be 180, the sum of the interior angles of a triangle. Take away 2 times 40, so take away 80, which then equals 100 degrees. So which angles does he use? 40, 40 and 100. There we go. I believe we have one more question left, so let's find out. Yes, indeed, a beautiful circle there, not to scale, of course, but what does it say? Before I read, let's have a look. I see a diameter there, that's important, a radius and a radius. So this must therefore be a right angle triangle, because that angle will always be half the angle at the center, so half of 180, 90 degrees. The diagram shows a circle with diameter AB and the center is O. C is a point on the circumference of the circle. Explain how you know that the angle ACB is 90 degrees without having to measure it. Well, that's what I just said. And how can you explain that? Easily, that is the angles in a semicircle, angles in a semicircle. Okay, if you're looking at a diameter, that means that that one has to be perpendicular because it's half of 180, so 90 degrees. AB is 13, they say. I don't see it in the diagram, so I'm going to write it down. AB is 13, so that's that diameter. And AC is 5. Calculate the length of BC. So it's a right angle triangle, so we can use Pythagoras theorem. Let's write it down. A squared plus B squared equals the hypotenuse squared. So always take a moment to find out, okay, what is the hypotenuse? Which one is the length across the 90 degrees? So in this case, that is the 13. So 13 squared equals 5 squared plus B squared. So we have to do some rearranging. 169, 13 squared minus 25 is going to be B squared. Okay, 169 minus 25 equals 144. But that is a little bit big for B. Yes, because that is B squared. We still have to take the square root of that. So the answer is 12. You see, you don't need a calculator for that even. Calculate angle ABC. So that is the angle over here. There you go. So you have to use some trigonometry for that. And let's write down SOHCAHTOA, top of our page. And let's find out, or let's choose one of the ratios to use. It doesn't really matter now because I know all the lengths. So let's choose the sine then. We say the sine of x or the sine of theta or a, b or c, doesn't matter, equals the opposite over the hypotenuse. So 5 over 13. There we go, 5 over 13. And then to find the angle, in your calculator you have to do the inverse, shift sin of 5 over 13. And if you want to write that down, you say sin minus 1. 5 over 13. There we go. So I'm going to take my calculator, shift sin, 5 divided by 13, and I'm going to do it properly. Shift sin, 5 divided by 13 equals 22.6 degrees corrected to 1 decimal place. So that was the entire paper. I hope it was useful. I was just answering the questions. If you have any particular questions about them, then check my website because I explain all of them in some form or format over there as well. I hope it was useful and I wish you all the best and hope hearing from you. Okay, take care. Bye-bye.